mode.
Hello everyone, I'm Gail Warren with the National Renewable Energy Laboratory, and I'd like to welcome you to today's webinar hosted by the Building America program. We are excited to have Lieko Earle, Bethany Sparn, Scott Horowitz, and Noel Marquette here today to talk about Building America research tools, specifically the Field Test Best Practices website, the Building Energy Optimization or BEopt software, and the National Residential Efficiency Measures database. Before we begin, I'll quickly go over some of the webinar features. For audio, you have two options. You may either listen through your computer or telephone. If you choose to listen through your computer, please select the option in the audio pane. By doing so, we will eliminate the possibility of feedback and echo. If you select the telephone option, a box on the right side will display the telephone number and audio pin you should use to dial in. If you have technical difficulties with the webinar, you may contact the GoToWebinar's help desk at 888-259-3826 for assistance. If you would like to ask a question, please use the questions pane to type in your question. If possible, please indicate when your question is addressed. If you are having difficulty viewing the material through the webinar portal, you may find PDF copies of the presentations at the website listed here, and you can follow along as our speakers present. Today's webinar is being recorded, and the recording will be available on the DOE YouTube channel within a few weeks. We have an exciting program prepared for you today that will focus on Building America research tools that support best practices in the building science community. Before our speakers begin, I will provide a short overview of the Building America program. Following the presentations, we will have a question and answer session, closing remarks, and a brief survey. The U.S. Department of Energy's Building America program has been a source of innovations in residential building energy performance, durability, quality, affordability, and comfort for 20 years. This world-class research program partners with industry to bring cutting-edge innovations and resources to market. Building America is supported by 10 industry research teams and 4 national labs. Each of these teams and labs partner with dozens of industry professionals, including builders, remodelers, manufacturers, and utilities. The best and the brightest in the residential buildings industry can be found here. Building America uses applied research to deliver building science solutions using a 4-step framework. These innovative solutions are tested in homes to develop proven case studies of success the market can point to. Building America provides the tools the building industry needs to ensure the innovations are applied correctly, always keeping an eye on energy performance, durability, quality, and affordability. The final step, infrastructure development, is the conduit to getting innovations to the marketplace. Building America research focuses on how the components of new and existing homes work together through systems integration. As the market changes and evolves, so has the direction of our research in order to add value and drive changes in performance across the home building industry. In addition to technical challenges we have been addressing for decades, there is now a need to understand market transformation issues such as valuation of energy efficiency. In the 20 years of Building America research, we have spearheaded combining ultra-high efficiency with high performance in both new and existing homes, and we are consistently achieving this challenging task. For example, in 1995, a typical home used 3 times more energy per square foot compared to today, and indoor air quality, comfort, and durability problems were common. Today, a home built to DOE Zero Energy Ready Home specifications uses less than half the energy and is more comfortable, healthy, and durable. By 2030, Building America will demonstrate that new and existing homes can produce more energy than they use. Do you want to know more about these proven innovations? The Building America Solutions Center is your one-stop source for expert information on hundreds of high-performance construction topics, including air sealing and insulation, HVAC components, windows, indoor air quality, and much more. You can find it by the URL on your screen or by searching on Building America Solutions Center. Also, the Building America website provides information about the program, the latest top innovations and case studies, and there you can also subscribe to the monthly newsletter. And now, to today's presentation. Our webinar today will discuss Building America research tools, specifically the Field Test Best Practices website, BEopt, and the National Residential Efficiency Measures database. If you would like information about any of these efforts or are interested in collaborating, please feel free to contact our presenters. Our first speakers today are Lieko Earle and Bethany Sparn from NREL. Lieko leads the field testing efforts for the Building America program. She focuses on field instrumentation and experiment design to evaluate emerging energy-efficient technologies, lab studies of sensors and controls for grid-connected buildings, home energy management tools, and field test methods for residential retrofits and new construction. Bethany's research concentrates on residential HVAC equipment, heat pump water heaters, non-intrusive load monitoring equipment, home energy management devices, and the whole house performance field testing. Next up are Scott Horowitz and Noel Marquette, also from NREL, who will present information about the Building Energy Optimization Software, or BEopt. Scott leads NREL's residential building team's analysis area, which includes building energy modeling, optimization, accuracy, and technology pathways. He is also the lead developer of BEopt to support Building America researchers and energy efficiency goals. Noel's work at NREL focuses on the National Residential Efficiency Measures database, field data repository, and BEopt software development. With that, I'd like to welcome Lieko and Bethany to start the presentation.
Okay, so here's a brief outline of our presentation. I have a couple of slides first on the project motivation, why we embarked on this multi-year effort. Then I'll give a general overview of the website and describe the types of information that you'll find on it. And then for the second half of the presentation, Bethany will give a live demo on how you can contribute your particular area of expertise to this project. She'll show you how to get a user account and edit or create new content for the site. So here's the short story of why we created this web tool. Over the years, as we've worked with other labs and BA teams, oh, sorry, I forgot to advance the slide. Also, I have to ask, can you see the, no, I can't get rid of this thing. Okay. Sorry, technical difficulties. Okay, so here's a short story of why we created this web tool. Over the years, as we've worked with other labs and BA teams, we've realized that there are some key gaps in our field test support efforts. First, it was apparent that we needed to do a better job of covering the basics. The success of a field monitoring or experiment project depends in large part on how well you plan it to begin with. And there are some essential components to any good field test plan, like articulating good research questions or assessing the current state of knowledge, and doing a preliminary simulation study so that you have some idea of what you're expecting to see that are really important. We realized that we needed to collect concrete examples of well-written plans, cleverly designed experiments, and well-documented conclusions so that they could be a resource to people planning new experiments. The second thing is, there were a number of us on the residential team here at NREL who started around the same time, about 5 years ago. And we quickly became involved in several field tests. Many of us had backgrounds in research, but were new to residential buildings, so this was a great way to learn a lot very quickly. And that's when it hit us how difficult it was to hunt down specific guidance on field test methods. A lot of field testing is kind of like folklore. There are tips and tricks that you just don't know unless you've done it, or talk to someone else who has done it. So collectively, there's so much practical knowledge that the Building America community has accumulated over the years, but it's all spread around between various technical reports and emails, and in many cases just in individual brains scattered around the country. So we realize that there's a need for a central repository for all this information. Third, we all have different aspects of field testing that we're good at. And we have a tendency to focus on things that we're good at, but a rigorous whole home field test requires a bigger picture. We need to maximize the amount of useful information that can come out of every field test opportunity. This can only be done if the resources are available to help you step through your entire plan in advance, Think through every experiment and analysis carefully. Anticipate all of the problems and make sure you're not missing any key pieces of information that you'll later need in order to make meaningful conclusions. So to address these needs, we created, or I should say we are creating, because this is a continually evolving process, a new web resource that we call Field Test Best Practices. The goals are to organize and make publicly available all this information, to use a dynamic medium, this is why we chose a web format rather than paper, so that it can be continually revised and added to. We're essentially crowdsourcing the documentation so that anyone who has a login account can edit or add new content. And our primary audience was the Building America community, but that simply gave us a place to start, and we envision that this site will serve and be served by a much broader community of building scientists moving forward. So, what does this site look like? Here's a picture of the home page. There's a rotating slideshow featuring a few topics, and then we've organized some landing pages to facilitate searching for content from 3 different perspectives: field test start to finish, building components and systems, and measurements and instrumentation. And I'll talk about these 3 landing pages on the next slide. And then there's a search bar in the top right corner, which is probably, in most cases, the easiest way to get to a specific piece of content. So the content on this website is organized in a unique way so that each piece of information lives by itself and not buried in a directory kind of structure. In other words, the page containing information, for example, on blower door testing, doesn't live inside the infiltration section. There are separate pages for infiltration and blower door testing, and they're linked so that you can get from one to the other. As I've mentioned, we've organized the content in a way that allows users to search for it from 3 different kinds of perspectives. Field Test Start to Finish gives a list of topics that are centered around general guidance on field test planning and execution. The Building Components and Systems landing page will be useful if you're looking for information on how to test specific appliances or building systems. For example, if you're looking at the heat transfer through a foundation or the installed energy performance of a central air conditioning system. The Measurement and Instrumentation section lists the types of measurements that you might need to make for your field experiment. For example, how to measure electrical energy or how to measure different kinds of temperatures. The 3 landing pages are designed to help you find what you need quickly. For example, you might be looking for information on thermocouples, but if you're doing a field test on a water heater, you might get to this information by starting on the Building Components and Systems landing page and following the links from the domestic hot water page to the appropriate temperature sensors. Or you could start in the Measurement and Instrumentation section and click on the temperature page to find the appropriate section. Either way, you'll end up on the same piece of content. So here are just a few sample screenshots to give you an idea of the level of information that you'll find. On the left-hand side, you see an introductory page on thermocouples, and then linked below are separate pages pointing to different thermocouples for different applications. The orange arrows on those topics that point to the right indicate that these are links to separate pages on each of these topics. So what you see here are only the introductory paragraphs for those other sections. But if you follow those links, you'll get the separate pages. A whole page on immersion thermocouples, a whole page on surface mount thermocouples, and a whole page on bare thermocouples. Same thing on the right-hand side. There's an introductory page on electrical energy with some basic information, and then several separate pages that discuss various aspects and hardware used in measuring electrical energy. The site is flexible enough to accommodate more than just text. You can put tables in, diagrams, and photos. So here are some examples. Here's a table showing the different kinds of flow meters and estimated installation costs. On the bottom, there's a photo of a CT installed correctly with labels indicating how you would position it so that the source and the load sides of a CT are pointing the right way. In the bottom right, there's a diagram on the best method for positioning immersion thermocouples. So the site features lots of sort of specific guidance and diagrams on how to install things. The site is open and free to the public to use, so anyone can view the site and search for content. But in order to contribute new content or edit existing content or participate in the user forum, you'll need to register on the site and receive a login account. One thing I want to be clear about is that this platform was sort of inspired by the likes of Wikipedia and created with the vision of crowdsourcing practical field test knowledge. We've done our best to populate the site with content around what we see as the most common needs, but we certainly don't have all the answers in-house. And it's a pretty vast array of knowledge that we're looking to document. So not to mention that methods and equipment are evolving all the time. So the more people use it and contribute to it, the more useful it will become. So we invite you all to lend us your expertise. Most of what's currently on the site was written by us at NREL, and also a fair amount of contributions we've received from the Energy Center of Wisconsin. And finally, I want to introduce a new feature on the website, which was actually technically launched several months ago, but we held off on announcing it because there were some bugs with the functionality that we wanted to resolve before we had visitors. We have a brand new facilitated forum for informal exchange of ideas among the user community. The point is to allow users to have casual conversations about direct experiences, including, for example, pros and cons of different hardware or software products, and ask other users for input on particular problems that may be circumstance specific and not the kind of thing that you want to create a general purpose content page for. It will be facilitated by NREL staff so that questions don't end up in a black hole, and so that we can make sure nobody posts anything offensive. And now Bethany will give a short demo of the site.
Okay, so here we are on the main page again. This should look familiar. So we have the rotating slideshow that Lieko mentioned, and then there are the landing pages for the three different sort of topic areas: the field test start to finish, building components and systems, and measurement and instrumentation. So they are listed on the front with sort of an abbreviated set of topics, and then they are also available along this top bar so that you can access them from any page. So field test start to finish, as we mentioned, is sort of a big picture overview. Things like experimental design, field test considerations, data analysis, and reporting are discussed here. You'll notice in the outline here that some pages have links and some do not. We are constantly working on new content and definitely looking to you for your help. Building components and systems, again, as Lieko mentioned, is more focused on different parts of a building, appliances and equipment that you might find and might want to do sort of targeted field tests looking at different systems. So we have them broken out by different groups, things like envelope, HVAC, hot water, and then different sort of more specific components under each topic. Measurement and instrumentation is more focused on the different sensors and measurement techniques that you might need during your test. So you can get at things in a lot of different ways. So let's say you're interested in liquid flow. You want to measure water flowing out of a water heater. So you might start on measurement and instrumentation and come over here to the liquid flow page. So here we have a general page talking about why you might want to measure liquid, usually water, things you might consider like cost and labor to install. And then down below we have links to and summaries of a number of different types of flow meters found on the site. So there's just a short little introductory paragraph showing, and you can click on the page you're interested in to find out more details. So this is a turbine flow meter page. We have a picture and some more information, and that might be where how you ended up here. Alternatively, if you were doing a field test of a water heater, say, you might start under building components and systems and go to the electric water heater link. Again, here we have some generic information on electric water heaters and a couple different types. Let's say you're interested in a heat pump water heater, and you can scroll down and see some recommended instrumentation, including water flow rate, which again takes you to the turbine flow meter page. So that's just a little bit of a demonstration of how you might end up browsing information. Alternatively, you could use the search bar, which is available from any page on the website. So let's say I'm interested in temperature. So I can use the search bar to search temperature. And I get a number of different pages dealing with temperature measurement, all sorts of different types of temperature sensors. So here is another way of getting at information depending on how you like to browse or search. So let's say you've been looking around the website, and we absolutely encourage you guys to go poke around and see what's here and what we might be missing. Once you find something that you're interested in or feel like we need a little bit more information to help beef up the topic, you might want to go get yourself a login. So go back to the main home page here, and you'll see the login button on the top right side. So you'll want to select the tab for create a new account. And here you'll enter information for a username, email address, name, and organization. This will help us just understand who's using the site and also make sure you're not robots. So we will, once you submit all of your information, site managers, which includes Lieko and I, will go through and grant accounts to all the non-robots out there. And this account will give you access to edit and create new content for the main site, and also to help you, and will also allow you to participate in the forum. Just like the rest of the site, you can view the forum without a login, but you will need to have an account to actually participate. So I'm going to log in so that we can look at a couple of different features for the creating and editing content. So when you first log in, there is a little wrench in the upper left corner, and that will give you this sidebar with a lot of tools. And I will also mention that I'm going to point you to a user guide that includes this and many more details of how to use the logged in features of the website. So don't feel like you need to be taking notes or anything. So once you're in, you're logged in, you're ready to go. One of the tools in this black top toolbar here that I really like is this content lookup. So this is a list of all of the different pages on the website in alphabetical order. So you can browse through there to find the topic you're looking for to get you started. So I'm just going to show you quickly what it might look like to edit an existing page. So here we have a page on condensing gas water heaters. And if you go to the tab that says Edit Draft, this page already has an existing draft, so we're just going to look at that. So we have the title up here. We have a summary, and that is that short paragraph that was getting pulled into other pages. And it's usually just the first paragraph of the body. And then in the body of the page, this is going to look like a pretty typical editing screen. It's a WYSIWYG, so what you see is what you get for the most part, I will say. Some pretty common formatting tools along the top, bold and italics, bulleted lists, numbered lists, subscripts, superscripts, that sort of thing. We can link to different pages on the website or exterior to the website. We can bring in photos, we can create tables, and do different formatting. I'll sort of just scroll through here. So here we have some links to other pages on the site, and we also have the ability to add equations using a standard LaTeX type of editor. So a lot of different tools out there that, again, are all contained in detail in this user guide I'm going to point you to in a minute. So once you're done, you're going to scroll down to the bottom of the page and hit Save. And you'll see that the screen will now show the same page with a red border, and it says Draft. So this will just clearly delineate which page is the draft and which is published. You're welcome to keep working on a draft for as long as you like. And then whenever you're ready for it to be sort of pushed forward, there's this drop-down menu at the top that gives you the option to push it into technical review. So once you're ready for that stage, you can just hit Apply. And technical editors, Lieko and I are two of them, will take a look to make sure that the content is accurate and relevant. And then we're going to push it to editorial review to make sure that all of the communication standards at NREL are met. And then it'll get published. So another thing I'll mention is that when we are creating new content, we really like to make sure that it's linked to other places so that it gets found by everybody. So when we put new pages in here, we'll make sure that we get it linked in a couple different places so that it can kind of live in this sort of dynamic space. So then, similarly, I'll show you quickly how to create a new content page. So also on this left bar, there's a button for Add Content, and you're going to add a page. So we have a title bar and the body, and you'll notice that when you start typing into the title bar, it's going to start giving you pages with similar words in the title. And this is just to try and help us make sure we're not duplicating information. So if I think that we're missing something, I want to create a page on pressure, but I see that there's all these other different pages about something to do with pressure. I might investigate whether what I was planning on writing is already contained somewhere else. If you don't think that those other pages are complete, we recommend that you edit those and add to them rather than create a new page that duplicates information out there. So in the body section, it's going to look similar. You have all the same formatting and editing tools, and you'll go down and save when you're ready. So I'm going to quickly show you where that how-to guide is, if I can get out of the page. Okay, so I'm going to go to the About screen, the About tab, which is available from any place you are on the website. So this is a little bit about the website, and then towards the bottom, I have mentioned that if you want to create new content or edit content, we have a Field Test Best Practices user guide. And this is a pretty detailed document with lots of pictures and lots of steps to help you navigate through the system of creating and editing content. And we are also always available via email if you need additional help, but hopefully that will get you started in the right direction. And the last thing that I wanted to quickly show you is the forum. So the forum, again, you can find on that main top bar from anywhere. This forum, we've already sort of populated with a couple of folders. They match the 3 different topic areas: building systems and components, field test start to finish, and measurement instrumentation. So you can pick one that you think best matches your question, come in here and create a topic. I've just put in a little welcome message to show you what it looks like. So first little message, and then we have a familiar looking comment area. You can type in text, you can add pictures, you can add Excel files, whatever you think you might need to add to help describe your problem or question to the group. And we at NRO will be monitoring this, so keep the discussion going, but we definitely encourage all of you to check out the forum and help the community with their questions. So that is your introduction to the Field Test Best Practices website, and I do hope you guys will all come and take a look. And I am all done and ready for Scott.
Okay, thanks, Bethany. So my name is Scott Horowitz. As Gail mentioned, I'm the lead developer at BEopt, and I'm going to give a bit of a highlight over the capabilities of BEopt, a little bit of history in terms of where it came from, and point out some of the unique, I guess, features of BEopt relative to a lot of other tools out there, and explain how BEopt came to be an important piece of the Building America program. So what is BEopt? So BEopt is a software program that you can download. You can install it on your own computer, run it from your computer. We sometimes refer to it as plug-and-play software, which is to say that BEopt itself is really just an interface, and it interfaces with existing simulation engines. And so there are existing engines like Energy Plus and Do2. Energy Plus is sort of considered the main simulation engine that BEopt uses. It's supported by DOE. It's their flagship whole building simulation engine. It does hour-by-hour or even sub-hourly time step calculations using detailed physics. And it's considered a very accurate and robust simulation engine. And there's a lot of software tools in the market that some of them will use, for example, Do2. There's other types of engines. Sometimes there are seasonal calculations and so on. But we really are trying to push Energy Plus as a more accurate representation of the energy modeling in the building. And so BEopt as an interface, the user will describe a building or series of buildings in BEopt. BEopt will pass information to the simulation engine in terms of an input file that describes heating, cooling, lighting, so on. It's a whole building simulation engine, as I said. Based on the weather file that you choose, it'll come up with your energy use as well as your utility bills. And that information will come back to BEopt. And when BEopt is running in optimization mode, it'll use that information to then say, all right, from all these different building components that you wanted to evaluate, this is an optimal building in terms of cost and energy savings. And it'll say, now, based on that, let's go ahead and look at some additional components. And it'll step through trying to identify optimal building designs all the way to zero net energy. And I'll go through that in a little more detail ahead. And so there's a BEopt. I'm not going to go through all of them, but I will mention that BEopt does work for both new construction and for existing building retrofits. The tool out there right now on the website, freely available for download, targets single-family homes. It has some simplified capabilities for doing attached walls, but we're actually planning to do a big release of BEopt soon with much more sophisticated multifamily capabilities. And then there's a number of other capabilities, like I said, in terms of costs, drawing of your building, utility rates, et cetera. So in terms of history of BEopt, it really started almost 15 years ago as a research tool in the Building America program, where we were trying to understand, well, first, I guess, 15 years ago, zero net energy buildings were not a common concept like they are today. A lot's obviously changed in the last 15 years. And so there's a lot of forward-looking people saying, we know we have this goal of zero net energy, and we know how to get small energy savings, but we really don't know what it looks like to cost-effectively get all the way to zero net energy. How much PV do you put in versus efficiency? What specific components should I put in? Even if I know what components could get me to zero energy, are they cost-effective technologies? And we wanted to be able to look for where there were gaps in certain areas. Is it more difficult to reduce the space conditioning? And so for the Building America program, it makes sense to do more investment in certain technologies related to that. So that was really the goal with BEopt, to try to optimize the sets of building components on the market to understand how far we are from zero net energy, what gaps are there, and what still needs to be done. And eventually, BEopt came to be officially released to the public in 2010, coupled with the Energy Plus simulation engine. Most recently, we've taken a redevelopment of BEopt into what's become BEopt version 2, released, I think, 2013. And so the current version of BEopt on the website then is based on BEopt version 2, and it's got a number of additional capabilities in terms of running batch simulations and a simplified interface and so on. And I just want to recognize that beyond the investment that DOE has made into the tool, we have had a number of different partners over the years, and most recently we're doing some work with the California Public Utilities Commission to add multifamily capabilities to BEopt, like I mentioned. We're planning to put out a release of BEopt at the end of June. That would be our first release of BEopt that has multifamily capabilities. I'll give you a quick sneak peek of that later in the presentation. And the other thing we're doing is that we've done some work with BPA in the Northwest, the Bonneville Power Administration, to make further improvements to BEopt and often, in fact, the Energy Plus simulation engine in terms of the modeling that's done for some advanced technologies. These are technologies like heat pump water heaters, mini split heat pumps, and some other areas that are sort of fundamental for residential buildings in terms of ground heat transfer and ducts and so on. So that's going to also make it into future releases of BEopt and Energy Plus in terms of a more robust model based on that project. So we're pretty excited about those recent activities. So here's just a quick look I'm going to give you of the interface itself. So we tried to strive a balance between keeping BEopt very simple and having a lot of flexibility for the user to answer lots of different questions and be available for power users as well. But it's very simple in terms of the way it's laid out in that there are just 3 input screens and 1 output screen. A screen where you define your geometry, some information about your site, including the location and economics and utility rates, and then the screen where you define your options or building components. You click the Run button, and then you get some output. So the interface is quite simple, and I'm just going to step through the screens to give you a quick look of what they entail. So this is the geometry input screen. The way this works is that for a given level, so here we are in the foundation level, you would select a space and you would drag your mouse and draw this rectangle here. And then you could select other spaces as well. And so you'd be drawing the floor plan of each level one by one. And on the right-hand side, while you do that, BEopt would be rendering that building, giving you a full 3D geometry of that building, which is important for your simulation modeling, both in terms of getting appropriate surface areas for all of your walls, knowing what surfaces are in contact with what. You know, that you have, for example, there'd be a wall behind this garage pop-out that is between your garage and your living space, things like that. And BEopt automatically does some roof generation as well. So it's a very rapid tool for getting full detailed 3D building geometry into the software. This is the same screen again. This is just a little bit of a sneak peek actually at our multifamily mode version of BEopt. We tried to keep it pretty simple to the single family mode. One of the main differences here is that there's this concept now of units in that you can have multiple units to define your building. So here's an example on the second story where I've got living space for 8 different units in my building, and there will be more on the first story as well. And you can see that creates this very large building with different units with windows and doors and that sort of thing. So this is how we anticipate BEopt being used to model an entire multifamily building. And there'll be some other modifications too in terms of systems in envelope measured and so on that you can look at in the context of multifamily buildings. So this is the first input screen, the geometry screen. So after you've done this, you've defined your geometry. You can then go to the site screen. On the site screen again is where you can specify this is your energy plus weather location. So this is a weather file that you can actually click this little down arrow and pick from weather locations around the world. There's some economic parameters that you can specify. BEopt does do full life cycle costing. The analysis period, for example, comes into place where if you were, let's say, in new construction and you're saying, I'm going to evaluate this highly efficient water heater, and the water heater maybe lasts 12 years, then in terms of the BEopt economic calculations, it would be doing replacements of those water heaters every 12 years up until 30 years, and then actually at 30 years there would be some discounting if you had extra years left on that last water heater. Information about your mortgage, so BEopt will do financing for both new construction and for retrofit as well. You can define incentives both for PV and for efficiency. Some information you can fill in just for your own notes in terms of the project you're working on. And then at the bottom here is where you define your utility rates for your building. For electricity, there's simplified utility rates, where you can either specify a user value, or you can pick the state average, in this case for Georgia, or even the national average. Or if you were to pick detailed utility rates, you could define very complex tiered, time of use, real-time pricing, things like that. And BEopt also does ship with a number of utility rates around the country that are based on this OpenEI utility rate database. So it integrates with that database and makes those all available to the user in a drop-down list. And then on the PV side, you can also specify net metering versus feed-in tariff, et cetera. So that's the site screen dealing with economics and location and utility rates. And then the last screen here is the option screen. On the left here are a series of different building components across various categories of building. So here's a number of different wall categories. You can see unfinished attic, roof, foundations down below. There's more in terms of equipment and appliances and lighting and so on. And for any category that you've got selected, then there's a series of options available to you to select from. So it's a very simple, quick, point-and-click operation of BEopt because we ship with over 1,000 options across over 100 categories. Has a wealth of building components available to you already. You can define your own if you don't see one in the built-in list that's made available to you and shipped with BEopt. In optimization mode, where you're trying to figure out what is the best series of, or combination of options, this is what you would do, where you could select a range of different wall constructions, and BEopt would evaluate them one at a time and come back and eventually tell you which one, based on your energy savings goal, is the most appropriate one for you. Whereas if you were just modeling a single individual building design, you'd be selecting just one option in each of these categories. So you would say, this is my wood stud wall option, this is my wall sheathing option, etc. And then after you were to choose all of the information across those 3 input screens, you would click Run. The Energy Plus simulations would run in the background, and you could get something like this. So this is the output screen for a sample optimization. And I'm going to talk a little bit more about how this curve comes to be. But essentially, it's a curve where the y-axis is energy-related costs, so it's a cost metric. And on the x-axis is energy savings. So ideally, you'd like to be as far to the right, as much energy savings as possible, and as far down as possible, so the most cost savings as well. This, as I said, was an optimization. Each of these points represents a combination of different efficiency measures. From a purely economic point of view, based on the building that we simulated and the components that we made available to the optimization, down here, these points here would be your most economic, sort of globally economic building designs. And generally speaking, these are efficiency designs, and then at some point, you would start to put PV on your house when it becomes the cheaper option. And then for all the results for these different simulations are saved, and you can select them. And based on what point you have selected, so here we've got a point selected at 80% energy savings, you get a breakout of the energy use in that design relative to your sort of baseline or reference design. So you can see the reduction in energy consumption based on efficiency, the smaller bars here. And also this line here represents the PV production. So not only do we have reduced consumption in our building in this 80% efficient building, but a lot of it is being offset with PV as well. And then on the right-hand side is a look at the options that make up, again, this specific building design. You can see there are descriptions over here on the right, as well as some cost information. So it's a very rich set of output available to the user to mine and find out exactly what building designs they're interested in, and be able to explore what is most cost effective for their project. So that was a brief look at the interface. I just want to take a second now to describe this concept of optimization in BEopt, which is really one of the unique pieces of BEopt, and we would argue it's really important, especially as you push out to zero net energy. And as I mentioned, BEopt started 10 to 15 years ago, and a lot has changed since then. And so it's important, I think, to always recalibrate yourself to recent changes, because 3 years ago, 5 years ago, you can take some time to figure out what you think is maybe a cost-effective building design given those times. But of course, PV costs have come down very quickly in recent years. Utility rates tend to trend upward. Natural gas specifically, of course, fluctuates a fair amount. And then, of course, there's always new technologies coming out in the market. Heat pumps, 3- and 4-pane windows, water heaters, clothes dryers, a lot of new technologies, and there'll continue to be new technologies. So the ability to have a tool to answer these questions on an ongoing basis as the context changes is a really important piece of BEopt. So this is a little theoretical diagram showing the path to zero energy, and it's all about trying to identify minimum cash flow designs at various energy savings levels up to Z&E. So here we have a theoretical diagram. On the x-axis, again, we have source energy savings, and on the y-axis, we have energy-related cash flow. And this energy-related cash flow is made up of utility bills plus mortgage costs. And we're going to focus on incremental mortgage costs to cover any efficiency measures that you make in the building. So we're going to start at a reference building. So this might be your baseline design. And at this moment, our building is made up of 100% utility bills. We haven't made any improvements to it yet. Then what we'd like to do is we'd like to find building technologies that will move us to the right. They'll save energy savings, and often they'll come at a reduced energy-related cash flow in that your utility bills for some technologies will actually be reduced more than the increment that it is required to pay for them. So over 30 years, if that's your analysis period, worth of utility bills, you can get savings, cost savings, relative to what you have to pay for that technology as it's rolled up into your mortgage payments. And sometimes at the very beginning, in fact, there's some no-cost measures that save energy and don't even cost anything. So examples of those would be reorienting your building or shifting some of your windows from one facade to another. So you can find such technologies that will reduce, that will be a net positive both in terms of energy savings and cost savings. But at some point, you're going to have a diminishing returns. And as you continue to put in new technologies in your buildings, the incremental mortgage costs will outstrip the savings that you get in your utility bills. And so this curve here will trend upward again. And if you were to continue to put on higher and higher, or I should say less and less cost-effective technologies, you would get something like this, where the curve would go essentially vertical and you can't get any more energy savings by doing efficiency. But BEopt will always evaluate doing additional efficiency versus the cost of employing PV. And so it looks at the marginal cost of saved energy from efficiency relative to the marginal cost of produced energy from PV. And at the point where PV is a more cost-effective technology, it'll put PV in your building to get you to zero net energy. And when you're at that point, now you've, in theory, reduced your utility bills cost to zero, and all of your energy savings improvements are rolled up in your mortgage. Now, of course, this is theoretical. There are some things to think about in terms of net metering. You can also have limitations on how much PV you can put on your building. So there could be some cap here where you can only put on so much PV, and then you might have to go back to efficiency. So this is a theoretical, and BEopt is not a theoretical tool. It will handle those types of situations in its optimization search. And one thing to point out also, or maybe two things. One is that the slope of this curve, back when we created this theoretical path to Z&E, was pretty steep because PV was pretty expensive. These days, PV has come down a whole lot, and so we should probably update this slope here. But actually, you'd expect PV to be a much shallower slope. And at some point, if cost of PV keeps coming down, it's possible that the slope could even become negative, which would be really interesting. The other thing that's worth pointing out is that there's a big difference between being on the left side of the curve here, back at your reference building, where you had 100% utility bills, and being at the right side of the curve, where you've got no utility bills and 100% mortgage costs. And that is that your mortgage costs don't change over time. By locking in your energy efficiency improvements to your building, you're really hedging off any possibility of future utility bill or utility rate increases over time. So you're locking in your Z&E design here, and you're not succumb to any changes of utility rates potentially increasing. So that's a really good place to be. So that's an advantage. So all things considered, if this was your if this is your starting point, and you could come all the way to the right and bisect that curve, again, you'd be getting energy savings in that new design. From a cash flow point of view, it would be identical, and you would have the hedge against some of your utility bills. So those are some of the nice things that moving towards zero net energy can get you. But this is a theoretical graph. How do we know what these efficiency measures should be? How do we know what this curve actually looks like as a function of PV costs and different climates, different building components available on the market? In theory, there's a range of lots of different combinations of efficiency measures that could get you anywhere here. And we would like to be able to find the lowest curve to all these points, find the least cost curve that defines this whole series of efficiency or building designs. And it's really important to do that because there are often a lot of ways to achieve energy savings and get to a certain point. So if your goal was 50% energy savings, maybe that's right here, you could be at this point here that has a certain cost relative to it, but you could also be way up here, and you could be paying almost double in terms of the cash flow associated with that design. So it's really important to try to find the cost-effective ways to achieve these energy savings. And so given this problem of trying to identify what these efficiency measures that make up the low-cost curve are, we put together a optimization strategy in BEopt called the sequential search. And here's the results. This is a very old result at this point, but it's a very good demonstration of what the sequential search optimization strategy does. And so here we are starting in a reference building. And again, every one of these points is a different combination of building components. So it's a building design. And BEopt iterated through and found this lower curve represented here. And so these represent first more efficient building designs in terms of energy efficiency. And then at some point you can see a transition to putting on PV to get the rest of the way to zero net energy. So this is an actual result from BEopt where we've demonstrated that, well, at least this sequential search can generate a curve similar to our hypothetical path to Z&E curve. But how do we know that it's actually finding low-cost measures? The point of optimization is that you don't want to run every possible combination of efficiency measures because that is a huge, huge, huge set of simulations, and that'll take a very long time. You want to be smart about what combinations of measures that you look at and run simulations with. So this is, several dozen simulations, but the full combinations that BEopt could have looked at would have been enormous. There would have been a giant cloud. So the question is, how good is this optimization search in BEopt? And we've answered that question. We went off and ran every possible combination of simulation. This was something like a week worth of simulation on, I think, 50 different computers. And so this gray cloud of point represents those 750,000 simulations relative to the 750 simulations that we ran on BEopt. It would have taken several hours to run versus days to run on 50 different computers. And again, the important things to note are that A, the sequential search has done a very good job at finding low-cost building designs. There's not gray points that are significantly below this low-cost curve. So that's great. That means we found some very good cost-effective building designs. And also, again, that for any given level of energy savings, BEopt is providing the user with a number of energy efficiency designs that are way more cost-effective than a whole bunch of other possibilities. You could be anywhere here if you were randomly trying to put together different components. So this is a good validation that the optimization search in BEopt works well. And so like I say, this is one of the unique characteristics of BEopt, this optimization search. And it's not the only. We certainly have capabilities in BEopt to just run single building designs. You can do single sort of what-if analysis. You can say, I want to look at one building versus A, B, and C. You can use BEopt in a much simpler way than the optimization capability but we think the optimization capability fits an important piece in the Building America program, and for builders and others as they look towards more cost-effective building designs. So the last thing I wanted to mention then on BEopt is just in terms of more resources available to you. I'd strongly recommend going to the BEopt website. There's a number of different pages on it. There's training videos that you can look at for more detailed information on how to use BEopt. There's a software help file both on the website and shipped with BEopt that's very good at explaining how to use BEopt. There is a forum that's quite active that we encourage you to post any questions to, and the sort of BEopt team developers look at that forum quite often and answer any questions there. And there are a number of different publications, different case studies, and so on using BEopt. So there's a wealth of material available to you. Again, BEopt is a free download available on the website. If you do register to the website, you can, we'll keep you updated in terms of new releases that come out, and if we host more webinars or training sessions like that. So that's everything I wanted to cover on BEopt, and at this point I'm going to turn it over to Noel.
Thank you, Scott. I am going to talk briefly about the National Residential Efficiency Measures database. One of the things you may have noticed when Scott was discussing BEopt was the multitude of options available for building components to be selected and used in those optimizations. Those weren't just made up out of the air. And they come from a database that we have put together called the National Residential Efficiency Measures Database, or Measures Database, for those of us who don't like to say that over and over again. And this is a screenshot of our website. And the purpose of this database is to provide a unified repository for residential building retrofit measures and associated costs. So this has within, can you read next screen? Oh, thanks, Scott. So what's in this database? We have the building component engineering properties. So this is systems, this is wall construction, this is windows, has the engineering properties that describe how they perform. It also has performance levels of those building components, whether they meet, for appliances, whether they meet federal appliance standards, Energy Star, for envelope components. It talks a lot about IEC codes. It also contains average lifetimes of the components, and also an average and a range of material and labor costs from kind of a distribution of what we found and what a contractor found of these components out there. So it also has labor costs too. So it also has combinations of efficiency measures that make sense. So you can say, well, I'm going to replace this furnace with one that's more efficient and would actually meet the federal standards, because sometimes older components wouldn't meet more modern standards. So here's an example of a measure you'd see in the database if you're browsing through that website, and I'll give you the link to that later. Our initial component is a 68% AFUE furnace. It uses natural gas, and say we're replacing that with a condensing furnace that has a 98 AFUE. You can see that it meets the all the new federal efficiency standards, where the old one didn't. You can see that it meets Energy Star, and on the right you can see a range of costs based on the different properties of the furnace. So that means for this particular one, it averages about $24 per kBTU age of capacity, plus $1,100. So it's kind of like a linear function based on how big the furnace is at that particular efficiency level. That includes both the labor and material costs for that measure. Of course, those costs are also available in the database, separate for each component, and the labor costs as well. So it just kind of rolls them all up in one view. I think the key thing here is, we have integrated this database into BEopt, and so, when you go through and you're looking at those options there, they come from our database. And of course, you can always create your own options. If you've gotten a quote or a whatever from, price from somebody, or properties for a technology that's not quite listed in the database the way you need it, you can always add it yourself. But this gives a kind of good general, like pick and choose database of options. For those of you who are software developers and wanting to use this in your own applications, we make this available through our website, and we also allow it to be downloaded, the entire database as a big XML file. And there's a screenshot of that on the right there, just a portion of it. And for more information, just go ahead and go to our website for the measures database, and there's it's all right there. So that's what I have.
Well, thank you all for those outstanding presentations. And we have time now for a few questions. We already have some great questions from the audience, and you may submit additional questions through the questions pane on your screen. Our speakers will address as many as time allows. So we have the first set of questions going to Lieko and Bethany. By contribute content to the field test best practices, does it show up on the website right away?
So Bethany did a quick demo on this. This is a good question. There is a little bit of a turnaround period because you will, once you create content, you will mark that it needs technical review. And our intent is to turn it around quickly. Some of that depends on the availability of expertise on our team. But we're thinking, no more than a few days, or it could be that same day if we're really fast. And then, of course, it has to go over to communications, especially if there are complicated tables and things like that. So there is a turnaround period, but it's not like weeks. It's more like days.
Okay, thank you. The next question is, I don't see any content posted under dehumidifiers, and do you have some clarification about that?
So this is going to fall into the category of content that we have not created content for. We are still working on content, so it's not like we are done at this point, but dehumidifiers is definitely a topic that is of interest to a lot of people in the community, and so it's high on our list. But if you have a lot of good information about dehumidifiers, you have experience working with them, we would love to get your input, and so reach out to us or write a page on dehumidifiers so we can get something on the website.
Okay, thank you. And the next question is, how do I know whether a topic has already been written about? Maybe I'm looking under the wrong header.
So this is also a good question. The easy way to check for that is to just use the search function that Bethany demonstrated. In most cases, it should be pretty straightforward. Like I think she showed a bunch of pages that had the word pressure in it. So if you're doing something related to pressure, you should be able to get to most things. Also, if you're starting to create new content, as you type in the proposed title, there will also be a drop-down showing all pages that sound like that title or contain that word. If you're really not sure, I mean, you haven't seen anything, but you're pretty sure that I don't know, you would find it hard to believe that someone hasn't already written something, you can go ahead and send us an email, and we do monitor the building field test email account. So, definitely ask before you reinvent the wheel. But it's also possible that no one's written anything yet.
Okay, and the next was more of a comment. If I'm in the field and need some info and don't have access to the internet, it would be nice to have a copy on the computer. Do you have plans for that?
We actually do have plans for this. This was part of the original plan for the website, but it's just taken us a little bit of time to get to it. So the original plan was to have sort of a shopping cart style where you could add a bunch of different pages to your shopping cart, and then when you were done, you could create a PDF of all of those pages that then you could save on your computer, exactly for that case where you were out in the field and didn't have access to the internet, but did have your computer with you. So it's coming. We're working on it. So hopefully it'll be a feature in the near future.
Also, you should be able to look up some stuff on your smartphone too. It won't be, we don't have a mobile specific site, so it won't be as pretty, but if you are in a place where your cell phone has data reception, then you should be able to get to some of the content.
Okay, and then there was another comment that said, please allow various sorts, especially date.
Various sorts, especially date. I'm not sure what that means.
I think they want to be able to sort
By
by.
Oh, sort. Okay, as in the verb.
Yeah.
By date of, most updated. So there is a way, if you are a content contributor, there is a way to view sort of the most recently updated content by date when it was last updated. So that's probably the easiest way to sort by date.
And then a final question is, what is the name of the software used for wiki-like editing of the Field Test Best Practices website?
It's a Drupal website. So it's all Drupal. And we have developers on site that are working through the different features that we're still trying to add. So that helps.
Okay, thank you. And then we have some questions for Scott and Noel. The first one is, does BEopt make the Energy Plus input files available?
Yeah, so it seems like there are a few questions with similar inquiries, I guess. So BEopt behind the scenes writes Energy Plus IDF input files, and those are available to the user to use. After you run a simulation in BEopt, you can go to the Tools menu, and then there's something called Open Data Directory, and that'll take you right to the directory with the input files. I should point out that once you have taken those input files, you can make changes to them and so on, but you'd be doing all that outside of BEopt at that point. There's no way to make changes to an Energy Plus IDF file and then sort of bring it back into BEopt if you want to run optimization on it. But it is a use case that we definitely get people that are maybe interested in certain emerging technologies, or they want to put in some sort of custom model, and so they can start off with sort of modeling the building as best as possible, and BEopt get a quick Energy Plus input file that's appropriate for residential building, and then taking that into the Energy Plus environment and making further changes there. So that is certainly a use case.
All right, and the next question is, can I obtain a HERS index score from BEopt?
So there are a number of software tools out there, of course, that provide a HERS rating or HERS index score. This is an area that we're actively discussing, the possibility of providing a HERS index score. We recognize, I guess, the interest that there is in terms of not having to do duplicate information in two different tools if you want to model your building in BEopt, but then you also need a HERS index score in another tool. So we're discussing a few different possibilities about how to do that, but I suspect that we will likely support that at some point.
Can you import your own 3D model into the BEopt software?
So at this point, I demonstrated the drawing tool in BEopt. We like to think it's a very rapid tool for getting full 3D building geometry 3D building geometry, and that is the primary way at this point to get geometry into BEopt. It can't accept at this point geometry from another tool. But like I said, you could, for example, take the 3D geometry from BEopt and create the energy plus input file from that and have that available. So you could export it to another tool, but there's no way to import that into BEopt.
Okay, the next question is, what is the baseline in the optimization graph to calculate the % savings against?
So there's sort of two answers to this. The simple answer is that as a user, you've got a lot of flexibility to define what that baseline or reference building is. You can actually go through building component by building component and describe what you want your reference building to be for optimization, or frankly for any energy savings value in BEopt, whether it's individual building designs or optimization. For the Building America program specifically, we have a few buildings that we've automatically defined as references. So for new construction, it's something called the Building America benchmark, and you can get information on this in BEopt through the help menu. But it's a building loosely based on IECC code compliance building, in that it's a building that changes as a function of where in the country you are, what climate you're in. And so that's meant to represent a typical new construction building of the same shape and size as your building, but with more or less code components. So that's for new construction. And then for existing buildings, if you're looking at retrofits, the existing building is essentially the default energy savings reference.
Okay, does BEopt handle utility rates with tiers, time of use, demand charges, etc.?
So I briefly touched on this. So BEopt, first of all, ships with a number, several thousand utility rates around the country for both IOUs and munis. And this comes from a sort of third-party website called openei.org. And in that website, which is a wiki-based website, there's a utility rate database that defines residential rates across the country. And so BEopt is automatically able to bring all that information into the tool so that if your utility is described there, you can simply choose that residential rate. And those rates can be tiered time of use. They can be both tiered and time of use. And it defines things with PV compensation as well. Alternatively to that, if you can't find the rate that you want, BEopt does also have a built-in interface so that you can quickly drag your mouse and define periods for time of use as well as tiered rates. And you can even enter a 8760 hourly real-time pricing utility rate if you wanted to do that. So it's got full flexibility for defining utility rates.
I'll go to one for Noel right now.
Sure.
What about the commercial building side for best practices and measures database?
I can't really speak to the best practices guides, but for the measures database, NREL commercial buildings team has created a very similar database called the Building Component Library. If you just Google that, you should be able to find it. That has many, many building components, and it is different format and everything. But I think that'll be what you're looking for.
Okay, and here's another question for Scott. Can a BEopt model be calibrated using real weather and utility data?
That's a good question. So I guess I'd answer that in two different ways. BEopt doesn't come with any built-in ways to calibrate or provide weather data. That being said, you can provide any type of Energy Plus weather file to BEopt. So if you put your real-time weather into a Energy Plus file format, BEopt will certainly use it for its simulation. And in terms of calibrating that to empirical data, beyond the output that I showed in BEopt that was all annual, there are ways to get results on like an hour-by-hour basis. And so you can, for any building design on the output screen in BEopt, you can click it, you can choose to obtain the hourly output data, and you'll get full hourly output data disaggregated by all the end uses. You can look at things like when your HVAC system is running, what the flow rates are, means water temperature. There's a whole lot of variables made available to you that would facilitate doing calibration. So BEopt certainly can be used for calibration, but it doesn't have any tailored interface, I would say, specifically for that purpose.
Okay, and then another question for Noel is how can the data in the measures database be improved? Are you looking for input from users?
Yes, there's a link on the measures database website. It says if you have data you would like to share with us, we would be happy to take it and have a discussion about how to improve the data in the database. I mean, it is based on a fairly robust data set, but it can always be better. So we'd love to hear what you have.
Okay, that's all the time that we have for questions today. Before we take our quick survey, I'm asking the speakers if you have any additional or closing remarks you'd like to make before we close the webinar. Okay. All right. Thank you. Now we'd like to ask our audience to answer 3 short questions about today's webinar. Your feedback will help us to know what we are doing well and where we can improve. The first question asks whether the webinar content was useful and informative. To answer, click on the radio button right in the GoToWebinar panel. The second question asks about the effectiveness of the presenters. And the third question asks whether the webinar met your expectations. Thanks for taking our survey. The April 7th Building America webinar is now open for registration. The webinar will introduce the integrated technology to market roadmaps that will serve as a guide for Building America's research, development, and demonstration activities over the coming years, and result in a research to market plan in 2015. Also, you can subscribe to receive notices about upcoming webinars and other news at the URL on the screen. On behalf of the Building America program, I'd like to thank our expert speakers for presenting today and our attendees for participating in today's webinar. We've had a terrific audience and we appreciate your time. Please visit the Building America website to download a copy of the slides and learn more about the program. We also invite you to inform your colleagues about Building America resources and services. Have a wonderful week, and we hope to see you again at future Building America events. This concludes our webinar.